All right, are we ready to start? Just a quick announcement, it's election season, and so we have a deadline coming up. If you can vote in the US, you have until tomorrow to update your registration. So as a college student, you can vote either in your hometown or here in Duluth. You can vote either place, but you should check and update your registration wherever you're going to vote there. You can do it online until the 15th. After the 15th, you just have to go in person and do it in person there. When you vote, in Minnesota, you can update your registration for your when you vote there. So I just want to remind you that October 15th is the last day you can vote. You can update your registration online. Also, just a quick reminder, you can vote in person early. So I've already voted in the election. I did it by mail, but you can go in Duluth anytime between now and election day and vote. There's 2 sites in Duluth where you can vote every day. Well, not weekends, some weekends. So I don't know if any of you attended the Ask Your Professor Election Democracy Immigration session last week, but they recorded it. So I also, if you want to learn more about the election and stuff, the Ask Your Professor stuff, I included a link to that here. So, okay, that's your announcement for today. So I opened up 2 units, unit 7 and 8 today. Unit 8 we'll do next week. We'll do the midterm exam, but I know some people like to start getting prepped for the midterm exam and stuff like that here. So I open it up ahead of time and look do it. We'll talk more about this probably on like Friday when we do practice exercise. But one thing I do allow you to do is get some extra credit for the practice problems here. I allow this now and before the final exam, and so it's not due till December 15th. But you can do multiple practice problems and submit them for extra credit here. There's also a review guide here, and again next week we'll spend Monday and Wednesday reviewing, and then we'll do the exam on Friday next week. So that's what unit 8 is, but we're doing unit 7. This is week 7, so we're doing unit 7 this week, and we're going to talk about methods here. So we'll do a pretty normal week. Today we'll go over the learning activity. Wednesday, we'll start the practice problem, this learning exercise and the discussion. I mean, not the practice problem, the learning exercise, and we'll start this weather program. It's important you do that because your assignment this week is based on that problem for that. So, and again, Friday will be our review day to work on the practice problems or work on the assignment or things like that. Okay, so let's jump into the learning material for this week. So we're getting here, so our code is getting a little more complicated, a little longer, and we're beginning to want, I think you might start wanting to organize it a little better. And this week we learn how to do methods here and how to organize code into blocks and use those blocks again and again. We call it methods in object-oriented programming like Java. In block programming, it's called like my blocks or custom blocks or procedures there. So if you're in CS principles, you may have seen it there where you created your own procedures or your own blocks. Sometimes it's called subroutines for this or functions. But the whole idea is to take parts of your code and break it off into a separate little unit so that you can call that method, that function, that subroutine again and again. Just to motivate you, here's a solution to the diamond problem. We didn't remember last week we tried to print off triangles and put the triangles together to print off a diamond, or diamonds, and the goal was to print off 3 diamonds. So here's the code to print off 3 diamonds, and this is, I think, about as small as you can get it here for this. So we have our main routine. We ask how many stars they want, read that in, and then we start our loops. So we have to loop 3 times to print off the 3 diamonds, and then we have to print off the up half of the diamond to do it. So we have to do all this loop, and inside that loop, we do another loop. So right away, we have a for loop within a for loop within a for loop. So we have 3 levels of for loops here. One's printing off each diamond, one's printing off each row in the top half of the diamond, and one's printing off then the spaces of each one, and then we print off the stars here. And again, it gets complicated. So, you start looking at these braces and go, where does this brace fit here? Now, sometimes your IDE will highlight that, so it's a little easy. Sometimes there'll be lines drawn in here. But again, if you're just looking at this code like this, it's hard to tell, even with the indenting properly done, it's hard to tell what's in this loop and what's in this loop and what's in this loop and what is this loop and where is this loop inside this loop or not? And then we have this whole second section of for loops. Here's another for loop and another for loop and another for loop here. So we have 1, 2, 3, 4, 5, 6, 7 for loops here. And again, I think this is the most efficient way to do this with the fewest number of for loops. Here we have 7 for loops just in this one program, all these braces and stuff. And a lot of this code will look surprisingly the same here. So we have this code to print off the stars. That looks a lot like this code for printing off the stars, but is it the same? Is it different? Could we, there, and then this code for printing off the spaces, is that the same as this code for printing off the spaces? We have this loop here, looks a lot like this loop here. Are these 2 loops the same? Could we, use the same code? You're going, oh, this one's minus, this one's plus, plus there, so slightly different. So again, we have code, a lot of code that is nearly the same. So again, we're going to use methods because our code is getting more complex. We want to organize it. And code is getting repetitive at times. We want to combine identical or similar sections here for this. So we're going to use methods for this. I'm going to jump into Think Java to start this. Here's how we would define a new method. We'd say public static void, and we'll talk about that void later on. It won't always be void. We'll say public static void, and then some name with parentheses, like new line, and then we'll start a brace, end a brace. And we can do what we want in here. So like this one just prints off a new line, an empty line. And now anywhere in our code we want to do a new line, we can just call that. We repeat this, the name of the method and the parameters. In this case, there are no parameters. There's nothing in the parentheses. And so when we call it, we don't put anything in the parentheses. So this will print off an empty line here. So again, prints off the first line, prints off an empty line, a new line, and prints off the second line. Main is actually a method itself that the computer itself will call. It has to be called main because it's a special method that our operating system knows to call and set up for that. So we always have to have a main method, but now we can add other methods and we can call them here. Here's some other examples. So here's the new line method. Here's a 3-line method that calls new line 3 times. So we'll create 3 new lines. So now if we call, if we say print, and then we call 3 lines, that will call a new line and print out a line, call new line again, print out a line, call new line again, and print out a line. So that'll actually print off 3 lines and this. So our output would be first line and then 3 blank lines and second line there. So again, you can have methods like new line, and you can have other methods, and any method you call can call another method here. We can organize this. I always kind of think of this like as organizational boxes and stuff like that. Like in your closet or in your drawers or whatever, you have you might have a box to keep everything organized, and in that you might have other boxes to keep other things organized. So there's, we're just kind of dividing it up. So we're creating a new line method, and then we're creating a 3-line method, and inside that it has the new line methods called for this. Now it gets kind of complicated for when we're trying to trace out our program. We always start at the main, because that's what the operating system will do, and we'll go line by line through that. So here's our first line. It's going to print off first line. We're going to go to the next line. Now this one jumps up, and so we put a little bookmark, a little mark here, say, oh, we're leaving this. We're going to jump up here, and then we're going to do 3 lines. We're going to do everything at 3 lines. When we're done, then we're going to return back here. So we remember where we are, but now we go up to 3 lines and start executing that. And now the first thing is new line. So again, we remember where we are here, and now we jump up to new line and execute all the code in there, just 1 line, and we go back. So now we go back. We know we left a mark here saying we left here, here. And then we go down the next line, and that is going to go back up here, do this line, and then we return back down to here. So we've done that. And again, we're going to do that again. So every time we leave a little, cookie crumb, a little bookmark. Somehow the computer knows that we were last here. We go back up here, do this line, come back. Now when we're done with this, we're done with 3 lines. We know this is where we called 3 lines. So we go back here, we did this, and now we can do our last thing. We can go down here. So we're jumping around a lot because, again, whenever we get to a method, we go up and do all that method, and then we come back here. So it's a little more complicated to kind of follow where you're at with this. So this talks about the flow of execution here. Now, another thing we can talk about is parameters here. In all of these ones, we didn't have anything in the parentheses. And that's fine if you want to do the exact same thing, if your code is exactly the same. So like here, this method for printing off, or this loop for printing off spaces, is exactly the same as this loop for printing off the spaces. So we could put those in a method and they do the exact same thing. But if you have something that's similar, so this loop and this loop are similar, but they're not exactly the same. So again, if you want to do stuff that's similar but not exactly the same, we can use parameters here. So let's say we want to print something out twice here, but it's not always the same thing. So we can say print twice. So again, public static void for now. And then we're going to say, so we always say public static void. And we say, give it a name. We're going to call it print twice, any name we want. And then we're going to give a parameter. So this is a little variable we're declaring here. It can be any type. Here we're declaring a string and giving it some name. And that means that within this method, we can use that string, that S. So we can print it out and print it out again. It prints out twice. Now, what makes this powerful is that now in our main program, when we call print twice, inside the parentheses here, we pass in a string. And this copies the string up here. So when we start print twice, it'll initialize S to be whatever we pass up to it here. So whatever we pass up to S. So in this time, don't make me say this twice. is passed up. So S is equal to that string, and it prints that out twice up here. So this will allow us to make methods where we can pass up a number and then use that number in our method. So maybe one time it will do something 3 times, another time it'll do it 4 times or something. We can use that number, or we can pass up different strings to do things different ways. So when we look at our code and we see parts that are similar but not always the same, we could say, well, what are the difference? Can we make those differences a parameter so that every time we call it, we can pass up something different to that method and do it differently? Okay, let's look at an example of this here. I have to kind of ruin your day a little bit today, so I apologize ahead of time for doing that. We're going to do the hokey pokey. Well, we're going to have the computer do the hokey pokey. Yeah. Okay.
From the seed.
So this is the hokey pokey. If you grew up in the United States, hopefully you learned the hokey pokey at some time. If you didn't, welcome to our world. But it's a typical kid song that talks about body parts and stuff. So we did one of the legs. Okay, I know the suspense is kind of killing you. You're wondering what's next, what body part are we going to do? And you're thinking, why didn't he find a better version of hokey pokey? And I'll tell you, I looked at a lot, a lot. I looked, and I think this is the best version of the hokey pokey out there on YouTube. Okay, you can do Barney, you can do the all these other, but this guy has a certain amount of personality that really resonated with me. So it may not resonate with you, but this guy really resonated with me. Sorry about that. Okay, what's our next body part? You're asking? Okay, it gets a little repetitive, and that's the goal, is that we want to see that, but it's different, but it's repetitive every time. So that's our goal, is we are going to write a program to do the hokey pokey. Oops, that's the hokey pokey, history of hokey pokey. Here, I'm going to bring up this GitHub hokey pokey code here. Let's see. I'm actually going to copy that whole code. So I'm just going to copy this URL, and I'm going to go over here and I'm going to go to team git clone. I'm going to paste that in here, and I'm going to clone the code because there's a couple different versions of this code here. Okay, so if you're looking in here, if you just follow this link here, we'll start with this method, the hokey pokey without any methods. So this is what we're starting with here. So that's the first one we're going to look at, is start with hokey pokey without any methods here. So I'm going to bring that into Bright's, into NetBeans here. So again, you can also just copy and paste this over here. And we just print off the lyrics of the song. So we do the right foot in, we do the right foot out, we do the right foot in, shake it all about. And then we do the hokey pokey, we dance self around, so we print that out. So that's the refrain. We do the first verse with the right foot, we do the refrain, we do the second verse with the left foot. So again, we print that out and we print out the refrain here. Then we do the next verse, we do the right hand, left hand, the whole self here. So if we run this for this, make sure we're running. It just prints off all those lyrics there. And what I like about this is it has some good repetition that we can work into methods. Very similar to how like this code here has repetition, but again, sometimes it's a little harder, at least to see that this and this are exactly the same there. Eventually you'll get to the point again where you start seeing that, but when you're first getting started, I think it's easier if we just do something like this, where you say this, the refrain, and the refrain is the same. And again, by now, maybe you have that song going in your head, you know, where you're going, oh yes, the refrains. Okay, this is the refrain. The refrain is the same every time, right? There. So we have different body parts, but the refrain's the same every time. So, so again, one of the things we're trying to do is we have this refrain again and again and again in our code. We want to move that into its own method here. So we're going to make our own method for this. Now, we can put it above the main method or below the main method. It doesn't matter. You can do either. I think I'm going to put it below the main method. So how am I going to do that? We're going to say public static public void. So we'll always use those three words, and then we'll give it some name. I'm just going to call it refrain, and then parentheses for any parameters, but I'm not going to use any parameters in this first one, and then a parenthesis or brace and an end brace here. Okay, so that's mine. And again, very similar to the main public static void. So if you're ever wondering what, you know, what were those words again, those are always the same. The name of the method and then parentheses. So we're going public static void, refrain, no parameters, nothing in parentheses, and then we're starting our bracket. Now we're going to do the refrain. So I'm actually just going to copy the refrain out of here. I'm going to just copy it and paste it in here. I already have code that does that. Okay, so now I have code that does the refrain. Now I'm going to call this refrain. So right up here, this code I'm going to replace with the refrain here. It needs a semicolon after it up here. So I'm just going to say refrain, and that's going to go down here and do these 4 lines, these 4 print statements, and then return. So everywhere there's a refrain up here, I'm just going to replace it with this refrain call. So now I don't need this one. I just replace it with this one line. I don't need this refrain. Replace it with this one line. I don't need this refrain. I just replace it with this one line. Here's one more refrain. So already, I think my code's more readable here. I do my right foot, I print that out, then I do the refrain. I do my left foot, do the refrain, do my right hand refrain, left hand refrain, whole body refrain. So I can see that refrain, and then I just have the refrain defined in one spot here. So I've taken this code and put it back down there. Questions on that? You're thinking, I'm kind of forgetting that song, and you're going, I'm not sure I remember how the song goes at this point. That's okay. There's another verse, right? Okay, that's good. I'm feeling better now. Amazing how music just kind of soothes the soul, right? The right kind of music just gets to you, right? So, okay, so let's do the next one. Um, Now, sometimes we do things just to organize our code. So again, one of the reasons we do this is just to organize code in different ways. So we can do that. So we have this verse for the right foot and a verse for the left foot. They're different. So I couldn't just, they're not exactly the same, but I could still put them in methods. So I could have a method down here for each body part. Now I'm going to do that. So static, public, void, and I'm going to do left foot. Now again, with my method names, I tend to use camel case. Start with a lowercase letter, and then if I get to another word, I switch to an uppercase. So I'm saying that, I mean, you don't have to do it that way, but it's a standard practice there. It's just like your variables, to name them the kind of the same way. So now I'm going to go get my left foot code here. Oops, where's my left foot? This is my left foot code. I'm going to copy it and put it down here. And then I'm going to call it up here. So here where it says left foot, I'm just going to replace it with this call. And again, I need a semicolon when I call it there. So again, I moved it down here. Now I could do the same thing. Static, public, void, right foot. No parameters in here. And so up here, I'm going to take this code. I'm going to get rid of it and replace it with right foot. And down here, I'm going to put that code down here. So it's basically just like, again, you're taking these, I don't know if you have some closet just full of junk, and you start taking that out, you put it in a box, you label that box, and then you put it back in there with a label on. So it's kind of just organizing our code. So again, we're grabbing, rather than having all this mishmash of code here, we're going to grab this right-hand code here. We're going to bring it down here. We're going to do, put it in a box, static, public, void, box, and we're going to do, we've done, so let's do right hand. And then up here where it is, we can do right hand. And then we're going to call that code from here. So now our code's looking a little better. I'm going to get rid of a couple of these blank lines in here. So our code, our main program is just going, we do right foot, we do refrain, we do left foot, we do refrain, we do right hand, we do refrain here. So our main program is looking pretty good. We can do these last couple methods if we want. And then we have all these methods down here for this. And that's what it's showing here. So here's here's our hokey pokey with just the refrain as a method here. And then we do that refrain. Now, again, here's this with each of the body parts. Now, in this one, again, we can call our methods anything we want. We called ours left foot and right foot here. Here we're calling it verse 1, refrain, verse 2, refrain, verse 3, refrain. So here's our refrain method, public static void refrain, that's the name. And here's public static verse 1. And here's public static verse 2. We get into big arguments about, is this a better name for this method than this? And should you be calling it this or this? So, you probably have your own opinion. Which one makes more sense? Would you rather see it like this? Verse 1, refrain, verse 2, refrain, or would you rather see it? Is this more meaningful? Or, if you had to edit it at some point, which one would you like to be? So fine. There's different ways of doing it. But again, same sort of stuff. We're moving everything into methods so that our main is much more organized and smaller. So again, this part didn't actually when we did our refrain, we shortened our code because again, we had the refrain in there 5 times and now we just have it 1 time. So our code got less. Now we didn't. Our code's actually a little bit longer because we have now a line up here and we have lines down here for each verse. So now our code's actually a little longer, but we've reorganized it. It's more organized maybe. Computer people don't get paid lots of money to organize their code. So we give it a different name so that sounds very complicated. So then we get paid lots of money to do that. Okay, so we refactor our code. Doesn't that sound mathematical? We refactor our code into factors here. So this is what we've done. Refactoring means reorganizing your code. So it does the same thing, but it's better organized there. But your manager thinks you're doing impressive work when you say, oh, I'm refactoring the code. So you just say that. So next time someone asks you why you're playing, oh no, I'm refactoring that. So that's what we're doing. We refactored it here. So we've refactored the code this way. And that's looking pretty good here. But I don't know if you've noticed this. Do you remember the song? Maybe you don't remember the song. Here. But even the verses have a lot of similarities in them. Okay, here comes the next verse. Now, you have any idea what the next verse is going to be like? It could be a totally different verse. So there's a little bit of predictability in each verse. Even though it's a different body part, still a little bit of predictability, right? So can we make use of that here? So again, left foot and right foot, you put and there's a body part in, and then here you put your body part. These could be the same if we just had a string. If we could give it a different string every time for the body part here. So it'd be cool if we could write a generic version of this. So I'm going to try that. I'm going to make a copy of this here. And I'm just going to call it verse. And I'm going to pass in I'm going to need a body part. What is it, an integer or a string? It's going to be a string. And oops, in this world, it's a capital string. And I'm going to call it body part. So now when I print this out, can I do this with my body part here? So I'm going to say, put your, and then end that quote, and I'm going to put in my body part. And then I'm going to add the rest of the string here. So let's maybe put in a little spacing here so it looks a little better. So I'm going to say put your body part in and do the same thing. So down here, I'm going to do the same thing where it says left foot, I'm going to insert the body part. And here where I say left foot again, I'm going to insert the body part. So now I have a generic verse here, but when I call it, before there was never anything in the parentheses. Now when I call it, it has to have a string inside the parentheses here. So I'm going to move that up here. And so now whenever I call, like here, if I'm going to do the left hand, I don't have a method to do the left hand. I never did that. So now if I want to do the left hand, I can just replace that with calling verse. But up here, I don't say string body part. I actually provide a string, left hand. So that'll take the string left hand, go down to my verse, initialize body part to be that string, and then print out. You put your, what did I pass in? Left hand. You put your left hand in, left hand out, left hand, and you shake it there. So, and then again, this one is the whole self here. So I could do the same thing. I could delete that whole thing and replace it by calling verse and passing in this guy's whole self. Get rid of some spacing here to clear things up here. So now I can do that. Now, if I can do that for these verses, I don't really need, right now I have a separate left foot, right hand. I don't need those anymore. I can get rid of those. Right now I have a verse here. I can do that. I can just say verse right foot verse left foot. And verse right hand, I think was the last one here. So now I have just two methods, a refrain and a generic verse that needs a body part. And then I can do this. I can say verse with the right foot, refrain, verse with the left foot, refrain, verse with the right hand, refrain, verse with the left hand, refrain, verse with the whole self, refrain here. So I can set that up. And again, when I run it, again, I've just been refactoring. When I run this, it'll print off the exact same thing here for this. Questions? So these are methods. We'll be using these a lot going forward to organize our code for this stuff. Again, if you remember, or if you're in CS Principles now, or if you remember CS Principles, there's something similar in CS Principles. Oops, actually, I want to be in App Inventor. Where we talked about you'd look at code that was similar here, like this dot size or whatever displayed, and then we made a procedure for that. So in this case, we made a procedure, and there's a way of doing procedures. Again, we call methods, they call them procedures. You could create a procedure, put anything in there, just give the procedure any name. So like I say, we could have said refrain as our method up here. And then we could have then maybe displayed in some place the refrain and called that. So once you create the refrain, then the refrain, call refrain is an option here. And I don't know if you remember or if you've gotten to that point, there's also a ability to add methods or what they call inputs, parameters here. So, well, let's not do it through refrain. If we did a procedure called verse, we can add an input and we could give it a name like body part here. Oops. And then when we call that method here, when we call body part, we need to provide the body part. When we call the verse, we have to provide the body part here. So again, we could then add some text and say, oh, call the verse. So like in our method someplace here, we could be calling the verse and specify the body part, like the left hand here. And that'll copy left hand in the body part and then do this, whatever, displays or whatever we need over here. So again, this is similar. Almost every programming languages have this. It goes by a couple different names here. It can be called methods, functions, subroutines here for this. Now, right now, we're just going to be doing void ones initially. Eventually, we'll talk about returning some values here for this, and they won't be void. We have to return some values. They actually do that in here. They have another kind of procedure, which I don't know if you use that much. A procedure will return some result here for this. Now to call, so get result. So to call this kind of procedure, you have to call it a little different. You call it, but it returns some value, so you have to store that value somewhere else here. And again, we'll look at that same sort of stuff later on. Okay, so we looked at Think Java. Let's look at CS Awesome a little bit. So they talk about calling methods without parameters here, and this is what we did initially. They go through an exercise where they have a turtle and they're making the turtle go around. They talk about this abstraction, procedural abstraction, and that's kind of what we did, breaking our code up into parts for this. I don't love their description. It's okay. I just think it's a little overly complex for this. And then they talk about calling methods with parameters here, where you can pass a parameter, say go forward 100, go forward 50, you pass in a distance maybe to a turtle. Again, not bad. And again, today I'm not going to get into methods that return a value. We'll wait till Wednesday, but that'll be our next thing here. So again, Think Java talks about parameters and arguments. I like Think Java a lot here. So again, this is where we say print twice and we pass in a string for that. Multiple parameters here. So with multiple parameters, you can specify one thing, comma, another thing. You just have to make sure you pass them in the right order here. I also say that beginners often think since they're declaring this, you say int hour, int minutes here. When you call them, you should do the same thing. when you call a method, you only have to specify the parameters like this. You don't have to say the type for that. So I'm not going to get into stack diagrams today. Internet programming talks about, again, this procedural abstraction here and how we can break things in. And again, abstraction is what CS Principles talks about. They talk about static subroutines here a little bit. They talk about parameters, passing a parameter in to a method for this and getting the result back. I really think the best one of these, if you want to just pick one, is the Think Java for new students here. I think the Think Java for this. I usually like CS Awesome, but I don't like CS Awesome's explanation in this. I like the Think Java one better for this. So. Okay, so we did our example with hokey pokey. Chris walks you through a version with this math example. What he does is look at this math routine where we can print off a menu and we have these different choices to add, subtract, multiply here. We talk about doing it with some different methods here. Like the initial one is just the method to display the menu for this and some other ways of doing it. So he has a number of videos that walk you through that. So feel free to walk through that example. My preference, I think the hokey pokey example is better because it comes with the song. Can't beat that there. But if you like the math example, Chris walks you through that also. So, okay. Wednesday we'll start our doing this with this weather program and looking at this sort of stuff. So and then remember there's a whole bunch of practice problems. So we'll see you on Wednesday here. So. Did you see you, Bruce? So just put my name in there. Yep. Oh, yeah. Yeah, I just changed. You can put these actually in any order. So just so you have all three of them there. It doesn't matter. Okay. Yep. Good day.
I made a mistake with the distribution in Bryce, so I personally sent it to your mail, so it can be sent to me.
Right, yeah, I saw that. Yeah, I haven't graded it, but we'll try to get that. So thanks for sending that. Okay, no problem.
Las que enseñaban son las que mal. Las preguntas que enseñaban al final son las que hiciste mal. Eso queremos con Alberto, no estamos seguros.
Yeah, thank you. Yep.
I'm supposed to reply to people's discussion, right?
Right.
Again at 6.
Yep.
There is no discussion posted, or I don't see anyone's post. Doesn't.
Hello.
I think it was Harry Potter.
Because I go to activities and go to unit.
Nickel.
Yeah. Oh, I think it's set up, so have you posted your code yet?
No.
So I think you have to post your code before I can see everyone else's code. Okay? I believe that's how this one is set. Because everyone's posting the same basic code. There. I should set that up. I should be able to fix that, but.